Ammonium metavanadate is one of the most important vanadium compounds and is a common precursor to vanadium-based catalysts, as well as the usual source of pentavalent vanadium in laboratories. I had a previous video on synthesizing the compound from metallic vanadium, but the method is quite expensive and doesn't have high yield. This video demonstrates a much more practical method that is cheap, reliable, and produces a rather pure product. I first weigh out 17.7 grams of anhydrous sodium carbonate and dissolve it in around 150 ml of water. The exact amount of water isn't critical. I slightly heated the mixture to speed up the dissolution and then weigh out 25 grams of vanadium pentoxide. Some people claim that it is available in pottery supply stores as a pigment, but I personally purchased it online from a chemical store. Just beware that commercial vanadium pentoxide tends to be very impure and contain lower oxides of vanadium and even oxides of other metals, so try to get the best grade available. Under rapid stirring, the vanadium pentoxide is added in small portions to the hot sodium carbonate solution. The orange vanadium pentoxide immediately reacts and dissolves, producing colorless sodium metavanadate and carbon dioxide gas. Note that the reaction is rather exothermic and releases a lot of gas, so adding too much vanadium pentoxide may cause splattering of toxic vanadium-containing solution. Even worse, hazardous fumes and aerosols could be produced and inhaled. Hence, wear gloves when in mosque during this step, and add the next portion of vanadium pentoxide after the last portion fully reacted. After adding around 3/4 of the vanadium pentoxide, the mixture turns to an opaque yellow-green. This is due to impurities in the vanadium pentoxide, such as vanadium trioxide and iron oxides, that are insoluble in the basic solution. Simply continue to add the rest of vanadium pentoxide, as a purification step later will remove these impurities. After all vanadium pentoxide is added, the stirring is stopped and the mixture is allowed to stand. The final pH of the solution should be around 8 to 9, as other vanadate ions such as orthovanadate, divanadate, or decavanadate may be produced if the pH is too acidic or basic, as shown in this diagram of vanadium concentration against pH. Some acid or base should be added to adjust the pH to weakly basic if required. The next step is a salt metathesis reaction to precipitate the relatively insoluble ammonium metavanadate from the vanadium-containing solution. For this, I measure out 30 grams of ammonium chloride, which is around 2 molar equivalents to the vanadium, and directly added it to the filtered reaction mixture from before. As ammonium metavanadate is notorious for being easily oversaturated and difficult to recrystallize, a large excess of ammonium ions is required to lower its solubility through the common ion effect. For this reason, I directly add the ammonium chloride as a solid without first dissolving it, to further increase the concentration of ammonium ions. After all ammonium chloride is added, the mixture is boiled on the hot plate to dissolve as much of it as possible and allow ammonium metavanadate to precipitate out. The solution's pH was tested to be neutral to slightly basic. After filtration while hot, we're left with quite a lot of crude ammonium metavanadate, as well as a colorless filtrate that also contains some more. For extra purity, I tried to recrystallize the crude ammonium metavanadate by dissolving it in hot water, but its solubility isn't great even in boiling water. Hence, this purification step is more of a trituration instead of a proper recrystallization to remove excess ammonium chloride and the remaining sodium chloride. Meanwhile, some crystals also formed in the previous filtrate as it cooled, so I filtered them out as well and combined it with my other batch to dry. After drying, the final mass of ammonium metavanadate is 30.0 grams, representing a 93.3% yield. This very high yield is mainly due to using minimal amounts of water and large excess of ammonium chloride compared to other methods. Ammonium metavanadate apparently decomposes over time, gradually taking on a slightly yellow color of vanadium pentoxide as it sits in air, but this contamination is minimal and doesn't normally interfere with applications. Thanks for watching, and see you soon.